Good afternoon, everyone. So in this video we are going to discuss about the signal flow graph. So the signal flow graph is invented by S.J. Machen. So he gave some formula about the signal flow graph, that is uh, uh, T is equal to 1 by del into sigma k into P1 del 1 plus P2 del 2. Like this the formula he is given. With the use of that we are going to find the transfer function or overall gain with the help of this signal flow graph. So here they are given the problem like this: find the overall transfer function of system whose signal flow graph is shown as like R of S is the input, the second node, third first to second node the gain is the 1, second to third node gain is the G1, 3 to 4 gain is the G2, and 4 to 5 gain is the G3, 5 to 6 gain is G4, 6 to 7 gain is G5, 7 to 8 gain is the 1. Okay, and also see over here some of the individual loops, that is 6 7 6. So here 7 to 6 gain is the minus h3, and 5 to 3 the gain is the minus h2, and 4 to 3 gain is the minus h1. But if you see 2 to 5 towards left to right they are showing over here, so that gain is the G6. Okay, in the signal flow graph, first step we are going to write down the number of forward path. Then second step we are going to do the number of individual loops. Third step we are going to check with the number of individual loop not touching. So those value are going to, those gain we are going to find out. Then we are going to find the del 1 value. Then after finding the del 1 value, whichever individual loops it does not touch the forward path, those gain we are going to find. Finally, after finding all those values, we are going to apply into the Machen formula. Machen formula is that T is equal to 1 by del 1 into sigma k. Denominator it will come k, not denominator. Below the sigma it comes k, and pk nk. Okay, the common formula. K is the number of forward paths. Okay, so now I'm going to solve the problem. So here first step we are going to find the number of forward paths. How many forward paths are there over here? We will check how many number of forward paths. See over here: 1 2 3 4 5 6 7 8. This is the one forward path. Another forward path: 1 2 5 6 7 8. So these are all the forward paths are there. Okay, that's what they are given here. There is two forward path, so that we are going to take P1 and P2. So 1 2 3 4 5 6 7 8, and 1 2 5 6 7 8. So there are, so the gain, so all the things is connected in the series manner, so we are going to multiply. So the first forward path we are going to take P1, second forward path we are going to take P2. So what is the gain? 1 into G1 into G2 into G3 into G4 into G5 into 1. So it will become G1 G2 G3 G4 G5. So the second forward path G6 into G4 into G5 into 1. So it will become G4 G5 G6. So that will be comes into the gain. So the next step we are going to find the which are the individual loops. Individual loop means starting from the node it will end the same node. Okay, so check over here. So this will be moves on towards right side, so it will not come as an individual loop. 3 4 again 3. So this is the one forward loop, sorry, individual loop. Then 3 4 5 3. This is the another individual loop. And 6 7 6. It will travel from 6 to 7, 7 to 6. So this is also another individual loops. So that is the thing we are going to return over here. 3 4 3 3 4 5 3 and 6 7 6. So we are going to write down the individual loop gain. Here the thing is, remember about the value P11 P21 P31, like we have to write over the individual loop. P11 is equal to G2 into minus H1, it will become minus G2 H1, and here G2 into G3 into minus H2, so minus G2 G3 H2 comes over here. In this individual loop P31 is equal to minus G5 into H minus H3, G5 into minus H3, it will become minus G5 H3. Now which are all the these two, this non-touching loop it does not touch. See over here, 3 and 4 nodes are there. 3 and 4 nodes it will become, so this both individual loops are touching over here. But you check over here, 343 and 676, there is no node is common, so that these two loops are not touching. Okay, so second one, those things we are going to check over here, 343 and 676. So here what is the thing, it will becomes p12 is equal to p11 into p31 is equal to minus g2 g3 h2 minus g5 g3 h2. So those values, if we are substituting, the gain we are going to get over here, p12 is a g2 g3 g5 h2 h3. Okay, same like one more thing is left out, 345 and 676. So 345 676, okay, that is like p22. So p22, it will become g2 g3 minus g2 g3 h2 into g5 into minus h3. So it will become like what, g2 g3 g5 into h2 h3. Okay, so that's what we're going to apply over here. So p22 value, so 1 minus of p1 p21 p31. What is the p1? So individual loop. Okay, calculation of del. So 1 minus p1. So the values, if you are substituting, you are getting over as a del value as a 1 plus g2 h1 plus g2 g3 h2 plus g5 h3 plus g2 g5 h1 h3 plus g3 g2 g3 g5 h2 h3. But what is the del value? So del is equal to 1 minus of number of individual loops plus number of 2 non-touching loops minus number of 3 non-touching loops plus number of 4 non-touching loops plus minus number of 5 non-touching loops. Like this it will be go, but only we have individual loop and number of 2 non-touching loops only is there. There is no 3 non-touching loops is available in this problem, so that you can omit it over there. Okay, after applying p1 and p2 formula, we are getting as a, this is the answer. Then finally calculation of del and del k. So here del 1, how to find the del 1 value is 1, because of check in this one, this is the individual loop, it will be touch the first forward path, yes, 3 and 4, and here 3 and 4 is common, even 3 4 5 it will be touch over here. Okay, so 6 7 also it will be touching over the first forward path, so that in the here del 1 we are going to take 1, because there is no individual loop is not touching the first forward loop, all the loop is touching the first forward path, so del 1 we are going to take 1. If we take down the second forward path, so here which is the loop is not touching, so because of 3 4, because the 3 4 5, here 5 is the common node, 6 7 is the common node, because 3 4 5 loop is 5, it will be touching over here, 6 7 6 and 7 is touching over here, but 3 4 3, so this loop is not touching the second forward path. Okay, so see 3 4 3, it's not touching that second forward path, so that in the second forward path we are going to take del 2 is equal to 1 minus p11. Okay, 1 minus p11, so 1 minus of what is the gain we are getting is a p11, that is the minus g2 h1, that you can substitute, we are getting as a 1 plus g2 h1. Okay, so this del 1 and del 2 value, p1 and p2 value, you can substitute over in the Mason's gain formula, that is 1 by del into sigma k into pk into del k, so 1 by del into p1 del 1 plus p2 del 2. Okay, so we substitute it, the final value transfer function or overall gain we are getting as a g4 g5 into g1 g2 g3 plus g6 plus g2 g6 h1 divided by 1 plus g2 h1 plus g2 g3 h2 plus g5 h3 plus g2 g5 h1 h3 plus g2 g3 g5 h2 h3. Okay, so like this we are going to get. Okay, here what is the p1 first forward path, del 1 is the number of individual loop not touching the which one, first forward path, that is the all the loop it touching, so that del 1 we are going to take it as a 1. So here del 2 value just we are found, so that value are substitute over here, so that we are getting del value already we found. Okay, if we substitute all the values, we are getting as the final transfer function is this. Okay, so like this way we are going to find the signal flow graph. In the signal flow graph, first step we are going to use the number of forward path, find the number of forward path. Second step we are going to find the individual loop. Third step we are going to do the find the whichever individual loop not touching, that we are going to find. And the fourth step we are going to calculate the del value. Del value is the 1 minus of number of individual loop plus number of 2 non-touching loop minus number of 3 non-touching loops plus number of 4 non-touching loops. Like this it will be goes, and finally you can apply into the Jason formula. Before Jason Mason's formula, one more step is the whichever individual loops is not touching the forward paths, so that value you can find the del 1 value. So finally those value calculated value can apply into the Mason's formula. So T is equal to 1 by del into sigma into pk del k. Okay, so finally we are getting the transfer function over here with the help of signal flow graph. Okay, so like this way we can find the transfer function of with the help of signal flow graphs. Thank you.